So, alright, we should be having our starters out, working on starter number 6. If you haven't done that already, you'll want to pull that out and give this a shot right now. Go ahead and pause the video. See if you can draw a triangle on the graph with these points provided to you. And then translate it to the right 7 and then reflect it over the x-axis. Alright, so this is how this is going to work. There's a couple ways to do this. In fact, if you remember the rules from way back in something like second quarter, first quarter, we actually had rules for these that you didn't have to graph any of these translations or reflections. There were also rotations involved with these shapes. Remember that a translation is a slide of a shape, a reflection is a flip, and a rotation is exactly what it sounds like. In this case, we're only dealing with a translation, a slide, and a reflection, a flip. All right, so starting off with the points A, B, and C, you should be able to graph those. A is at -1, 1. B is at -5, 1, and C is at -5, 6. I'm going to do that really quickly. All right, so this is where we're starting with A, B, and C. The next thing it asks us to do is to translate this triangle to the right 7. So we're just going to translate it, or in this case, we are going to be sliding it to the right 7 points. When we label our translation, we're going to label them as A prime, B prime, and C prime. A gets translated to A prime, B to B prime, and C to C prime. Okay, now we need to reflect this over the x-axis. Okay, over the x-axis means we're going to flip this thing over the x-axis. The x-axis is this axis here, so everything is going to be flipping down over that. From there, when we flip A prime, we're going to relabel it as A double prime, and so on and so forth with B and C primes. Remember that the important part of reflections is making sure that each point is reflected equidistant from that line of reflection. So for instance, A prime right here is a distance of 1 from the x-axis, so A double prime should maintain that distance of 1 from the x-axis. Same thing for A prime, all the double primes, A double prime, C double prime, and B double prime. That gives us this new triangle here. Right? It's not a new triangle. In fact, the triangles are congruent because they went through a rigid transformation, 2 rigid transformations in this case. And going all the way back to when we did these, rigid transformations preserve congruence, which means each of those angles are all going to be congruent. It also preserves side angle measures and side lengths, right? So each of these side lengths are actually going to be the same length as their corresponding side lengths all the way back to their original shape. All right, the last thing we would like to do is we generally label these off as A double prime, B double prime, and C double prime. For instance, A double prime is now at the location of 5, -1. B double prime is now at 2, -1. And then C double prime is at 2, -6. 1, 2, 3, 4, 5, 6. 2, -6. All right, so you should know how to label those points. The important part here is, do you know how to get to those points, right? We were asked to actually draw these out in this case, but we can actually do these transformations with A, B, and C without any graph. And those are some of the rules we talked about, but that's not what this problem asked for. Look forward to those coming in the future with those starters. All right. Put your starters away and we should be opened up to page 574. On page 574, this is going to go pretty quick. We are going to be using our calculators as well here, and just some know-how on how do we solve equations. In this case, we want to know what the solution of this equation is, where y cubed, that's y to the power of 3 plus 15 equals 140. Right? And this is a simple equation. Starting off anyway, remember that we always try to isolate the variable when we're finding a solution to the equation. So the first thing that we're going to be trying to do here is trying to get the term with the y in it alone. So let's try that first by getting rid of that 15. 15 is a constant, and we can get rid of that whole term by subtracting it. But we have to be fair and equal to both sides of our equation. We usually use that lollipop to help us remember to do it to both sides. The reason why we do that is so that this term goes to 0. 15 minus 15 is 0. So we're left with y to the power of 3, or y cubed, equals 140 minus 15, which is 125. You can use your calculators to do that, right? This next part, you might need your calculator unless you know your perfect cubes already, right? The way that we can get y by itself, so it's just y equals, is we need to get rid of that to the power of 3. We're basically asking ourselves, what number times itself 3 times would give me 125? And we've been talking about square roots and cubed roots. We can take the cube root to get rid of a cube, but if you do that to one side, you have to do it to the other, right? It's just an inverse operation, right? The cubed root of a cubed number is itself. So in this case, I'll kind of draw it out here. But this cubed and this cubed root will cancel each other out, leaving us with y equals the cubed root of 125. And if you remember, 125 is a perfect cube. We just need to figure out what that is. Either you remember it, or you have to go to your calculator. In this case, we're going to go over to the calculator. We're going to do cubed root. You'll notice that we have the square root button here, right, on our calculator, but also we have this little x root here. To make this a cubed root, we have to type in 3 and then click the yellow thing. So we have to go up to second cubed root, and you'll see how it puts that 3 up there. So now we're looking at the cubed root of 125, hit enter, and we get that the answer is 5. So really what that's saying is that 5 to the power of 3, 5 times 5 times 5 is 125. But our answer here is that our solution, anyway, is our y equals 5. All right, on page 574, we also have these 4. I bet you could pause the video and do these really quick. The square root of 0, if you didn't know, you could use your calculator, but basically that's just saying what times what equals 0. It has to be, those two things have to be the same, right? Something times itself equals 0 has to be 0. What about the cubed root of 0? Well, that means something times itself again equals 0. Again, that's the only number that's going to work there is 0. The square root of 1, what times itself is 1? Well, that would have to be 1. And the same thing for the cubed root of 1. What times itself again would be 1. That'd be 1. Again, you could use your calculator to figure that out. Let's see here on page 575, we have a square window that has an area of 16 over 25 meters squared. What is the perimeter of the window? So let's keep in mind that it's asking for the perimeter. And to find the perimeter of any shape, you just had to add up all the sides. In this case, we're dealing with a square, so we'd have to add each side to itself, right? So that's 4 sides we'd have to add up. In our case, because it's a square, all those sides will be the same. In this case, we are told the area, right? And because the area of a square is the side times its side, or its side squared, we can say, if we label our sides x, we can say that x squared is the area. We're also told that the area is 16 over 25 meters squared. From here, you can just solve for x like normal. Now, remember that when you're solving, I guess I should mention this here, when we are solving for our square roots, that's actually going to give us 2 answers, and we'll talk about that. But with cubed roots, it only gives us 1 answer. I'll kind of recap that here in a second. When we take the square root of both sides to get rid of a square, we need to remember that leaves us with a plus or a minus answer, a positive and a negative answer. Now in this case, because we're dealing with area, the negative answer doesn't make sense because we're looking for the side length, and side lengths cannot be negative. They can be 0 and they can be positive, but they can't be negative. All right, anyway, this lets me go with x equals, because the square root and the squared will cancel each other out. Those are inverse operations. And you can think of this side as plus or minus, and we'll talk about that again here in a second, of the square root of 16 over the square root of 25. And you could go straight to your calculator with this, and that's it. And I'll show you it out step by step, but you'll see both ways. Right here, we're going to have the positive and negative answer. The square root of 16 is 4, and the square root of 25 is 5. So our answers are technically plus or minus, or positive or negative, 4/5. However, we're going to ignore the negative answer because the side length can only be positive. So we're just going to say 4/5 by eliminating the negative answer. That's not the answer to the question, but let me show you this again. You can come over here to your calculator. We are doing square root, so we're going to go second to get to this square root here. You can type in a fraction under here and do 16/25. Hit enter, and it will tell you that it's 4/5. Now remember, your calculator will never tell you the negative side of square root answers, so just keep that in mind. We know that it is only positive 4/5 in this case because it's a distance. All right, now we're not done because that tells me that x is 4/5. Right, that only tells me that the side length is 4/5. The question is asking for perimeter, which means we need to add up 4/5 4 times. It's going to be 4/5 plus 4/5 plus 4/5 plus another 4/5 over here. Or another way to look at that is 4 times 4/5. Right? You can jump over to your calculator and do that if you would like, but we're going to have a bunch of 4/5. Where's my fraction button? There you are. 4/5. And then you can come outside of that and hit plus 4/5 again. But what I'm going to do is I'm just going to times that by 4 because that's the same thing as adding it 4 times. And that gives us 16/5. So the perimeter is going to be 16/5. Or if you'd like to see that as a unit fraction, we can go over here to convert it right here, second, and then click this button. And we'll change it from an improper fraction to a unit fraction. 3 1/5. In this case, it's only going to be meters because we're talking about a distance around an object. All right, so either of these answers are perfect. On page 576, we have this problem here. We have 5 times the cubed root of 3, all of that to the power of 3 or cubed. It wants us to rewrite this without any cubed root symbols. Okay, I'll show you how to take this all the way to the final answer. In fact, you could type this right into your calculator and call it good. But I'm going to focus on just getting rid of the cubed root. First off, we know that cubing something means to multiply that thing by itself 3 times. So this is 5 times the cubed root of 3 times 5 times the cubed root of 3 times 5 times the cubed root of 3. Right? That takes care of the exponent on the outside there. That's what that means. Now with multiplication, you can multiply in any order that you want. Kind of like 2 times 3 is the same thing as 3 times 2. We can reorder all this multiplication to say that this is 5 times 5 times 5, right? And then we have this times cubed root 3 times cubed root 3 times cubed root 3. Over here, let me highlight this. This is 5 times 5 times 5. That's either a calculator problem. It's 125. But we could rewrite that as 5 cubed, or 125, I'll get there. But then here's the key thing that we want to focus on today, on this problem, is what does this mean right here? Remember that if you take a cubed root of something times that itself 3 times, you're basically just saying, hey, we just want to know what's on the inside there. So what is under the cubed root, right? This is basically the same thing as when you have like x cubed. If I take the cubed root of that, it undoes the cubed root and the cubed, right? It gets rid of that, leaves you with what's under there, or the x in this case, right? It's the same thing when we take a cubed root of something and cube it, right? This cube is going to undo the cubed root, leaving you with just the x. So in this case, the multiplying this 3 times right here, or cubing it, is going to undo itself, leaving you with just the times 3. Like so. Okay. At this point, though, like we can't multiply 5 times 3 because we don't have the same exponent. We can't use the power rule. We could leave it like this because I have rewritten this problem without a cubed root symbol. I could take this further to say that 5 cubed is 125. And I could times that by 3. Over here, 125 times 3 is 375. Right? So that's also fine because that is also an answer without a cubed root. So this is without a cubed root, this is without a cubed root, and this is without a cubed root. And that would be answering, any of those would be an answer to the question given to me there. All right, let's see here on page 577. Kofi makes a candle as a gift for his mom. The candle is a cube with a volume of 8 over 125 feet squared. Kofi wants to paint each face on the candle except the bottom. Ooh, that's probably going to be a little tricky. Let's talk about it. What is the area he will paint? Well, this is kind of a multi-step part, not even a two-step part. Because first off, we only know the volume, which means I could use that to go find the edge length by using cubed roots. But then I have to find the area of each of the squares on each side. But then I want to multiply that by 7 because I'm only by 5 because I'm only painting 5 of the 6 sides of the cube. All right, so it's a little tricky, but it's not too bad. Let's see if we can go find the edge length. Remember that volume is each edge times the edge times the edge, right? Length times width times height would give us volume. In a cube, all those are the same. So if you want to think about it this way, I'm just going to call it the side. The sides cubed would give us this volume. To undo that cube, we just take the cube root of both of these. And you can do this in your calculator. But over here in your calculator, we want the cubed, right? So not square root, but cubed root. So we're typing 3 first. Second, click this button here to get you the cubed root. We have a fraction under here. It's going to be 8 over 125. And that gives us 2/5. And this is good because really the cubed root of 8 is 2, and the cubed root of 125 is 5. Now we know cubed root and cubes will cancel each other out, leaving with the edge length is 2/5. Nice. But that's just the edge length. It didn't ask for the edge length. It asks for how much paint, basically, we're going to be painting with. So I have one side of the cube would be 2/5 by 2/5. So the area of one of the sides would be the side times the side. So 2/5 times 2/5, which is 4/25. You could do that in your calculator if you'd like. But how many sides of this cube are we painting? It says, what is the area he will paint if he paints everything except the bottom? A cube has 6 sides. We're not going to paint the bottom. So we have 5 sides to paint. Because one side is 4/25, let's times that by 5. So 5 times 4/25. Right on over here to your calculator if you need that, okay? 5 times 4/25. Make sure I got everything in there right. Looks like I did. And that gives us 4/5. You also could have just multiplied straight across, giving you 20/25, or reduced is exactly what you see there is 4/5. And because we're painting area, we're going to be painting square feet, technically. All right. If you got the 4/5, you did the math right. But you can see how that's kind of multi-step. You use the volume to find the edge length, then you use the edge length to find the area of one of the squares, and you multiply that by how many squares you'll be painting. All right, and lastly, this is kind of just to plug in and see if it works. Basically, we're being told, hey, if y is this, then do we get this if we square it or cube it? So tell whether each value of y in the table is a solution for y squared equals 18 or y cubed equals 18. For our first one here, A, y equals negative square root 18. So if we were to replace this y with a negative square root of 18, you're basically saying negative square root 18 times negative square root 18. Well, negative times a negative is a positive. That's good. We want it to be positive. And then square root of 18 times the square root of 18, that's squaring a square root. That is 18. So this one does work. All right, next one. Y equals square root of 18. Well, let's try this. Square root of 18. Square root of 18, that's what that means, right? Or we can take a look at it this way. Maybe I'm kind of jumping the gun there for you. If I replace that, I'm checking this out, right? So if I plug in square root of 18, well, the square root and the square will undo each other, leaving you with 18 equals 18, so that also works. What about for negative cubed root of 18? Well, for checking this first one, You're going to have a negative cubed root of 18. The square and the cube do not undo each other, right? So this is not going to work out because I can't bust this 18 out of its radical prison, okay? So this is not necessarily going to be 18. I can't see that. So we're going to move on to the next one. Let's check it out, right? For y cubed, so y cubed equals 18. If we substitute a negative cubed root 18 in there, will this work? Well, this is interesting because remember that the cubed root of a negative is still negative because it's a negative times a negative is positive, but then that positive number times another negative is going to turn it back to negative. So this whole thing right here, while the cubed root and the cube will cancel each other out to 18, you're still going to be left with a negative 18, and negative 18 does not equal 18. Okay, so this didn't work for the squared, it didn't work for the cubed, so this is neither. Lastly here, for part D, what if y equals the cubed root of 18? Now that's looking a little more promising. Obviously it's not going to work with the square, but let's try it with the cubed, okay? Is this cubed going to be equal to 18? Well, is the cubed root of 18, that's this part right here, cubed going to be 18? Well, yes, because, again, the cubed part, power of 3, and the cubed root here are going to cancel each other out, leaving you with just the positive 18 from inside the cubed root, and then 18 over here. 18 does equal 18, so yeah, the answer is going to be, hey, it does work here as a solution. All right, that's all for that. There's an assignment that you need to be doing in part of this, so make sure you get that completed as well. I'll be quiet now. You go have a good one. See you later.